All right, so far in this unit, we've talked about 5 measures of center. And 3 of them have the word mean in it. So there's sort of the regular mean, the trimmed mean, and yesterday we did the weighted mean. Then there was the median, then there was the mode. And we talked a little bit about this as we've gone through the first 3 lessons with the 3 types of mean and median and the mode. But I just want to jot down a couple of advantages and disadvantages of each, right? Because it's something that could be fair game. So, advantage of the mean, really, it's a good measure of center. If there are no extreme values. And another word we use instead of extreme values, outliers. Which leads to, of course, the disadvantage of the mean. Not a good measure, or not, yeah, I'll say not a good measure. If there are outliers. You know, so like if we have 10, I don't know, 10 people in their income, and 9 of them have incomes in somewhere between 80 and 90,000, and one has an income of like 2 million a year. The mean is not a good measure of center for that, because that 2 million is an extreme value. It'll pull the mean up. It'll make it higher than it actually is. Okay? And we already talked about that. Which means that generally the median is a good measure. Okay? So it's good for describing typical values. And outliers have very little effect on it. The really big disadvantage of the median, it's time consuming to find. I'm just going to leave it at that. I'm not going to worry about adding anymore. Because we saw, like with the mean, you know, like if we're trying to find the average of 10 numbers, we just add them all up, divide by how many there are, away we go. But with the median, we have to take all those numbers, rearrange them so they're in order from smallest to largest. So you got to rewrite them all. Then you got to figure out what the center is. So it's a lot more time consuming than the mean. But it is a good measure because it is resistant to outliers. And finally, the mode. Well, advantage of the mode, really, it's useful for something called nominal data. And by nominal data, I mean data that doesn't consist of numbers. So where might the mode be good in this kind of case? Let's say baby names. You want to find the most popular baby name. Well, wouldn't that be the mode? You have a list of all the baby names, like say all the baby names in Winnipeg. You have a list of all the baby names, and then you just look for the one that appears most often. That's the mode. So that's what I mean, like, for example, baby names. Or election results, right? Because you're counting the number of votes for a certain person. And the one with the most votes, the mode, is the winner in the election of whatever it is. Big disadvantage, it could be very far from the center of data. Which really means, like, for numerical data, numbers, it's not a good measure. It's kind of hit and miss. Sometimes it might be close to the mean and the median. Sometimes it might be really far away from it, like really far below or really far above. It depends on what the data is, looks like. So you should be familiar, sort of in general, an advantage and disadvantage of each of those. So as an example, at a hospital that did a study to determine the typical age of patients hospitalized by two different viruses. So for virus 1, the median age of patients hospitalized was 30 years. For virus 2, the median age of patients hospitalized was 70 years. So your first question is, for virus 1, does the median age of 30 necessarily mean that many of the adults were around the age of 30? Can you give me, say, a list of 5 ages that have a median of 30 and yet the numbers are not really around 30? So if it's 5 numbers, this must be 30, right? Because it's the middle number. These have to be lower than 30. Sure. Here? Yeah, there's an example right there. So not necessarily. It's just the middle number works out to be 30. And the thing with the median is extreme low values and extreme high values will balance each other out. Okay. So here, that's another situation. So the answer would be not necessarily. I mean, we could have a situation where all 5 of them are 30. Or we could have a situation like this, where we've got 2 infants and 2 very elderly people, and 1 around the age of 30. If the median age is 70 for that second virus, what does that sort of suggest about the people? Yeah, they're older. Okay. I mean, if the median age is 70, you're going to get most of the ages that are quite older. Although I suppose you could put 70 in there and still work out to be the same thing, right? So it's possible, okay? So let's say one would think patients would be old, but it's still a log. What other information could we present? Oh, we found the median. What else could we find? mean, and even though it's not the greatest use, mode. Okay. So hopefully you're kind of getting the idea that it really depends on the data what we're going to be working with. So here's some data. We've got a list of 8 incomes of automotive technicians. Okay, we want to calculate the median. What do I have to do first before I calculate the median? Sorry? Put them in order. Lowest highest. So there's 20,000, 20,000, 20,000. There's 3 of them. 20,000. Okay, that's 23,000. 30,000. 35,000. 42,000. 58,000. Are there 1 or 2 numbers in the middle? Sure. Remember, if there's an odd number of data values, there's only 1 in the middle. If there's an even number, there's 2 in the middle. There are 8 data values in here. So there are 2 numbers in the middle. Because we've got 3 below those 2 numbers in the middle and 3 above those 2 numbers in the middle. That's the very definition of median. Same number of data values below, same number above. So to find the median, we've got to average those 2. So 23,000 plus 30,000 divided by 2 is going to give us 53,000 divided by 2, which is going to give us, what, 26.5? Okay. 26.5. How many values are below the median of 26.5? How many values in this list are below 26.5? 4. How many are greater? 4 again. That's a good measure of center, right? Because you got 4 below, 4 above. That gives us a pretty good idea of the typical. What's the mode? Go back to the data. It doesn't matter whether you look at this set or this set. 20,000. How many are below that? None. How many are above? Well, I guess technically we can say 5, right? Because 3 would be the same. So there's, none below but 5 above. That's not very balanced. That's not very typical. Yeah, you know what? I'm not quite sure why I put explain in. Because the only explanation, yeah, no, just take that out. It's not really good. Because this is kind of odd, like this, when you put these numbers in, it's kind of obvious. I should have put, explain whether this is a good or bad measure of center, is what I should have put. And finally, the mean. We'll just Just write it like this. We'll just go back to the original order of the numbers. We're not going to write them all. So these are the first two, and then we keep adding everything into the list until we get to the last one of 30,000, and we divide by 8. And I'm just going to give this to you as 31,000. So how many, now this, you got to go back to the order one again. So how many are below 31,000? 5. Which means 3 are above. Not a bad measure of center, but probably not as good as the median. Okay. And why is that? Can you explain to me why that would be? Why is this mean higher? What value in the data changed this significantly higher than the median? The 58,000, right? So the 58,000 outlier of 58,000 hold the mean higher. Okay, so you do want to make sure you have an understanding. And finally, which one? The median. And it is a good measure of center as 4 values are below it. 4 values in the data are below it. And 4 are above it. Can't say the same thing about the mode and the mean. Mean is pretty close, but the median would still be the good one. Right? Most times, like I said, median will be the best one, unless there's no extreme values in the data. Then you can really go mean or median. And then again, like I said, mode is this. The trimmed mean. Okay, remember the trimmed mean, that means we remove the lowest 5% of the data when it's in order and the highest 5%. Okay, so that's what we call the 10% trimmed mean. So what's good about it? Useful for data with extreme values or outliers because it removes them. However, and this kind of leads to the disadvantage of the trimmed mean, is that if there's too many outliers, okay? Not useful if there's too many outliers. Or extreme values. Thank you. Thanks. Oh, it's been a long day. And finally, the weighted mean. And we talked about the advantages yesterday when we did that lesson. Okay. Useful when data represents multiple people. So for example, if you've got the age, if you're trying to find the average age of a large group of people, and let's say 29 of them are age 43, instead of adding 29 43s together and writing them all out, you do 29 times 43. Much easier. And that's what we do when we calculate the weighted mean. I think I'm going to leave it at that one. I only want to sort of give you one to watch. I did put a couple others in the notes. There were other ones in less than 5.3, but that's sort of the big one. Okay. A disadvantage that we didn't talk about yesterday, it can be misleading. If the categories are given arbitrary rates or weights. That means it doesn't really make sense, the weights that they're given. It's almost like picking it out of the air. You know, so for example, you know, the average, to calculate the final mark for a certain course, you do, let's say for a science course, you do 10 labs over the year, they're worth 2%. You write 10 tests over the year, they're worth 3%. You write the final exam, it's worth 95%. That's kind of arbitrary. Okay? Although, when I was in business, University of Manitoba, there was 100% exam. No tests, no assignments, no papers, no projects, all notes, and it was on commercial law. Why are you doing that? Why? I'm new to business. Okay, maybe that's a law course. I think it was an elective, and they may have changed it. That was years ago. That was in the 80s. I don't know if it's that. You know what? At the time, back in the 80s, it was very rare. So I would say it's probably virtually impossible. Because, I mean, I just don't see how some people could get away with it anymore. Did they tell you that? Oh, yeah, you got that at the beginning of the course. So yeah, it said breakdown of marks, exam, 100%. Yeah, how many people didn't come to class next time? You stayed, right? Yeah, I did. How many people left? I don't know. It was probably quite a few. Probably what, this is nuts. Yeah, I mean, that was crazy. I think I got in the 70s, which I was pretty happy with. Yeah, because it was very stressful. It was like, I can't believe this. It's just like, you know, it's a 3-hour exam. So you go to class for like 4 hours a week for however many weeks, and then it's all based on 3 hours. Like, it's just crazy. Anyway, words in the English language vary in length. Shortest words consist of one letter. The word at or I. Here's the longest word in the English language, according to the Oxford Dictionary.
Pronounce it.
Not me.
Wait a minute. Give it a try.
Human ultra microscopic silico volcanoconiosis. It's not bad. Okay.
Is there a definition there?
I don't know, but I would ask one of the science teachers.
I saw spelling bee where it's all.
This word? Get out.
It's like the world spelling bee.
Really? Wow. Okay, so we've got a following paragraph about statistics.
Yeah.
So we want to calculate the mean, median, and mode of the number of letters in each word of the above paragraph. I know this is going to be a lot, so I'm just going to give the information to you. Okay. So just keep in mind that in order to find the mean, first of all, there are I've got the number here. There's 32 words. There's 32 words, and then for each word, we have to count the number of letters. We're not, no. I'm just giving you the mean. So it's 154 letters altogether in 32 words. You will not see anything like this, where you'll be asked to calculate it. You could be asked to interpret it. Okay, so you could be given the mean, median, and mode, and then say which one do you think is the best. Okay, so the mean would be 154 divided 32, which gives us 4.8. So according to the mean, on average, there are 4.8 words, 4.8 letters in every word in this little paragraph. For the median, again, this would be even harder because you would have to list all the words, the length of the words in order from smallest to largest. So there's a whole bunch of 2-letter words in here, a whole bunch of 3-letter words, a whole bunch of 4-letter words, some 5, some 6, couple 8, some 10, couple 11. What's that?
The periods where you count.
No. So I'm just going to tell you the median worked up to 4. And the mode, the number of letter words appeared the most, 2. Which one is the least appropriate? The mode. If another good question to ask, maybe you might see it, I'm not sure. If the mean is 4.8 and the median is 4, what does that mean? If the mean is higher than the mode, the median, doesn't that mean that there might be some high outliers? Okay, 1 or 2, we don't know. If it was below, there might be some low ones. So there might be a few words in there that are have an unusually large number of letters. Okay, last question. Don't worry. Yeah. Marriages and divorces. Yes. This is 20 years ago. I don't know how much times have changed. Okay, but at the time, yes, there were a significant number of divorces in Quebec compared to marriages. Okay. The total number of marriages, 3/4 ended in divorce. That's a pretty high number. Okay, okay. Whoa, hey, whoa. Let's keep things sophisticated. Okay. So we want to calculate the mean and median. We're not going to worry about this. I'll tell you what this number of means in a second. So to calculate the mean, we'd have to add all these up, divide by how many there are. To calculate the median, we would have to list them from smallest to largest and find the middle number or average the two middle numbers. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13. How many are going to be in the middle? One number in the middle. Remember, if it's an odd number of numbers, there's one in the middle. If there's an even number of numbers, there's two in the middle. So I'm just going to give you the mean and the median. So for the mean, we would have to go 29. I'm just going to do it 29.39 plus 34.43. Oops. Put that there. Plus dot to the end. 21.74 divided by 13. And that gives us a mean or average of 42.7%, which is pretty significant. I mean, it's almost half. The median, again, like I said, we have to list them, smallest to largest, and then the seventh number would be the middle number, and that middle number actually works out to 42.25%. So the mean and median are actually pretty close. But wouldn't you think that there was an outlier in here that you guys like obviously noticed pretty quickly? And that is Quebec.
Because they only have 69 marriages. So their percentage is low, but there's not a lot of people.
Yeah, so remember, this is what we talked about yesterday. Finding the mean of these is probably not very useful, is it? Because each of the provinces and territories have different number of people. Which is why, and I was going to tell you this, this is actually the weighted mean. Okay, 47.62%. Which is even closer to half. Okay, but this is probably the best measure. So I'm just going to add this here. This is the weighted mean. So how would we calculate that? Well, we would have to do the percentages times the number, add all those up and divide by how many weights or how many, how many weights there are. Anyway, just to finish this up. Well, the outlier is clearly the 75.12%. If we remove that, the recalculated mean actually goes down, which seems to suggest that there might be low outliers. And I mean, well, none of us could pull it down, right? While it shouldn't, right? Because if we just average the percentages here, none of us counts for equal weight as Quebec. But that's not true, is it? Because they don't have the same number of marriages and divorces. So really, another outlier could be considered none of them, because it's unnecessarily dragging down the mean. So is the mean you found in A or the mean you found in B the same value? Well, neither are the same. although A was closer. And why is it the same? Well, the trimmed mean, which is what we actually did in part B, pulled the mean down because of limits. That's why we got a lower result in B. And A and B, for A and B, the provinces and territories were giving people weight. But that doesn't make sense because they have different numbers of marriage and divorces, okay? Which they shouldn't. If they had the same number of marriages and divorces, then you could average out all the percentages. But because they don't, okay, that means we're not going to get an accurate measure of the mean. Okay.